So this is the third and final part of our electrical deep dive. I wanted to do one last problem, keep it fairly practical. And so let's just say I have this problem. Let's say I've got some given information. So I'm going to replace a light bulb, right? I've got a normal 60-watt light bulb, cost me $1. I'm going to replace it with a compact fluorescent light bulb. That's going to cost me $7. But the compact fluorescent light bulb only uses 13 watts as opposed to 60 watts. And I'm going to give you some other information. Electricity is 15 cents a kilowatt hour. Kilowatt hour is a unit of power, right? And I use the bulb 4 hours a day, right? 4 hours a day. So my question then is, shrink this down a little bit so we can read it, still read it, but my question, I've got a couple. So there's my questions. What's the resistance in each light bulb? And how long will it take to pay off my investment? Here I had to pay $7 instead of $1, so I had to pay $6 more to get this fancy schmancy bulb. How long is it going to take to pay off my investment? And I'm going to, write this for an assumption. We're going to assume that we're talking about one bulb, right, in a DC circuit only. I know that's not quite what we have in our house, but we're going to leave it there. And we're going to say that that DC circuit's running at 120 volts. All right, 120 volts. So let's solve this problem. How are we going to go about solving this problem? Well, first thing I'm going to do is I'm going to draw a circuit diagram. So, step one, draw a circuit diagram. I got a voltage here and a resistor. That's my whole diagram, right? And I know that in the first case I have 60 watts of power, and if I go and look at the previous lesson in this series, I can actually go calculate the resistance if I know the power, and I get 240 ohms. We already calculated the resistance of that light bulb. 60 watt bulb in a 120 volt circuit. The resistance is 240 ohms. And I'm just going to see the previous example here. Alright. I can redo those same essential calculations for my 13 watt bulb. I've got power is equal to V times I, voltage times the current. I know the power is 13 watts. I know the voltage is 120 volts. I can find then the current I is equal to 0.108 amps. And then I can keep going with that. With Ohm's law, V is equal to IR, the voltage is equal to the current times the resistance. I now know the voltage, 120 volts. I know the current of 0.108 amps, and all I'm left with is R. That's an R. So I got R then of 1,111 ohms. So power is energy over time, right? We know that. I did that a few lessons ago. Power is energy over time. So we'll need to use that in the next part here. But let's finish our discussion here. So our 60 watt bulb has a resistance of 240. Our 13 watt bulb actually has a much higher resistance, right? Much higher resistance. So that's number one. Number two, let's look at the power and the energy that we're going to use. A kilowatt hour, right? A kilowatt hour. Oops. Start moving things around. Stop doing that. Kilowatt hour is 1,000 watt hour. 1,000 watts times 1 hour. We know, again, like I just said, power is equal to energy over time, which basically means it's very similar to joules. This unit is energy. So a kilowatt hour is energy, similar to joules, which I introduced before. So if energy is equal to power times time, right? Using that same relationship, energy is equal to power times time. We can look at that. For our 60 watt bulb, we have energy equals power times time. So let's look at the energy use in a week. Let's look at the energy use in a week. So energy equals 60 watts times, let's see, we're going to use that bulb 4 hours per day, right? And there's 7 days in a week, and there's 1 kilowatt hour, or 1 kilowatt per 1,000 watts. So we can actually cancel out. I got watts on the bottom, watts on the top. I got day on the bottom, day on the top. I end up with kilowatt hours, and if I do all that multiplication, I get 1.68 kilowatt hours in a week if I use that 60 watt bulb. All right? Let's look at the 13 watt bulb. Same thing. I got energy equals 13 watts times 4 hours a day times 7 days in a week times 1 over 1,000 to convert those units, and I get here 0.364 kilowatt hours. So I'm definitely using less energy. How about the cost? Well, for my 60 watt bulb, the cost at 15 cents a kilowatt hour, I have 1.68 times 0.15 cost me 25 cents. I divided that by 100 to get in cents, by the way. Whereas for my 13 watt bulb, 0.364 kilowatt hours, multiply that out times 15 cents a kilowatt hour, and I wound up with 5.5 cents over here. So clearly it's going to cost me less money to run this 13 watt bulb. So just in a week I saved about 20 cents. How long is it going to take me to save $6? Which is the second question. How long will it take to pay off my investment if I got to replace that bulb with a $7 bulb versus a $1 bulb? So I have to make $6 in savings. So I can say 60 watts times 4 hours per day times, now instead of 7 days in a week, let's just say X days. I don't know how many days. Right? Times my 1 over 1,000 1,000 times my 0.15, that's dollars per kilowatt hour, minus my 13 watts, my other bulb, times 4 times X days, divided by whatever, 1,000 times 0.15, that's again dollars per kilowatt hour, and all that equals, so this is the cost of the more expensive to use bulb but cheaper to buy. This is the cost to run the one that's cheaper to run, like the compact fluorescent. All that equals $6, right? That's what I have to save, and I can multiply all the sort of nonsense terms here, all the numerical terms, and I can get actually this equation to look like 60 minus 13 times x, since I have an x in both terms, x and an x. This is about as complex as the math ever gets in this entire class. And that turns out to be 10,000. And I can find x. X equals 212.8 days. So approximately 7 months. So those are actually pretty realistic numbers. This is pretty expensive power here in Texas when I'm making this video, but it's not completely unreasonable. And 60-watt bulb, 13-watt compact fluorescent. So you could do the math yourself when you're standing there at Home Depot or Lowe's trying to figure out which bulb to buy. Excuse me. You can think to yourself, well, a few months from now, I'll have paid off my investment, and assuming the bulb lasts for, say, 3 years, I'm more than going to save my money by getting that cheaper bulb. So I hope this was a good introduction to electrical engineering for you. Just some initial concepts in circuits. There'll be a homework or problem or two in circuits and circuit analysis like we've done in class. Nothing more complex than that. Hope you enjoyed it. See you next time.